Hi class, this is section 2.3 on graphing. So let's look at some functions to graph. So the first question is asking us to graph f of x is equal to x minus 4, and they give us a domain to work with. So that's a domain, all the values between -5 and 5. So we can do this by drawing or creating an xy table. That's one way to do it. So the first value would be -5. And then that would give us, if you plug in -5 here, that's -5 minus 4, which is -9. Then you can keep on doing that. Since we're graphing a line, this is a linear function. We only really need 2 points. I'm going to go ahead and do 3 points. So I'm going to plug in 0. So if you plug in 0, 0 minus 4 is -4. And if we plug in, I'll plug in 5. If you plug in 5 take away 4 is 1. And so now if we create our coordinate plane, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So I went down to -9 and up to +9, and over here 5 and -5. And so our graph is going to go from -5, -9, which would be down here. And then it would go 0, -4, which would be there. And then 5, +1 would be about there. And those 3 points should be on a line, a straight line. And it might not be exact because my marks, my tick marks aren't exactly perfect, but you get the idea. And there you go. There's your line segment, and that's the domain here. So the domain is given to us. The domain is, they want interval notation though. So because of the equal sign down below, that means you're going to do close brackets on both ends. -5 to +5, close brackets on both ends. In the range, you're looking at the y-coordinates. The lowest value is -9, and the highest value is +1. So -9 to +1, and that would be it. This next one, same directions. This time, this is a quadratic, which means the graph will be a parabola. So for a parabola, I would recommend that you set it equal to 0. That's how you find the X intercepts. And then you factor it. In this case, it's going to be x plus 5, x plus 1, which means the two zeros are -5 and -1. Those are our x intercepts. And I would also recommend that you graph the vertex. The vertex is given by the formula -b over 2a. -b is a coefficient in front of the x, which is 6. So this would be -6 over 2 times the coefficient in front of x squared is 1. So that would be 1. So that's going to be 6 divided by 2, which is 3. That's the x coordinate. You still have to find the y coordinate. And you can do that by plugging in 3 into the function above. Then you will get 3 squared plus 6 times 3 plus 5, which is 9 plus 18 plus 5. Which is, what is that? 27 plus 5 is 32, I believe. All right, so now we have our vertex and we have our x-intercepts. That's all you need to graph a parabola. So coordinate plane, I'm going to create the x and y axis. I have to go all the way to 32. So let's see, 1, 2, 3, 4, 5. I'm just going to go by 5s. 5, 10, 15, 20, 25, 30. All right, so that's 30. This is 5, -5. So our vertex would be at 3, 32, which would be way up here, maybe about here. And our x-intercepts would be at -5 and negative 1. And I must have made a mistake. I did make a mistake. You could tell that this parabola is incorrect because I forgot the negative sign. Now that makes a lot more sense. Negative 3, that's going to change this value now. So that's going to change this to a negative 3, a negative 3. That's still a positive 9, but now this becomes minus 18. So that's going to change this and that. So now instead we have negative 9 plus 5 is 4, right? Negative 9 plus 5 is negative 4. All right, so we fixed our problem here. So now we're going to go down, and that's going to be 1, 2, 3, 4. And so now this makes a lot more sense. Negative 3, 1, 2, 3, negative 4 would be about right there somewhere. And there is our parabola. All right. Now we can look at the domain. Notice that the domain that this parabola is just going to continue to go to the right indefinitely, and it's going to continue to go to the left indefinitely. So this parabola is just going to get wider and wider in both directions. So the domain is going to be negative infinity to positive infinity. And the range, you're looking at the lowest y value. The lowest y value is right here at negative 4. And the highest y value is infinity because it's going to continue to go up indefinitely. So we would write that as negative 4, close bracket, positive infinity, open bracket. The next problem deals with the square root function. So once again, you can do an xy table, and you can plug in values for x. I'm going to plug in positive 3. We don't want to go 2 or anything less than 3 because then you'll have a negative under the radical, which is not a real number. So the smallest value you can choose here would be 3. Then I'm just going to go with 4. And then I'm going to think of another perfect square. I know 1 is a perfect square, so 4 take away 3 is 1, which gives us the square root of 1 is 1. 3 take away 3 is 0. Square root of 0 is 0. So the next perfect square would be 4. So I want to get a 4 here. The way I can get a 4 is if I plug in 7. 7 take away 3 is 4. So that's going to be my next x value. 7 take away 3 is 4. The square root of 4 is 2. So now we have enough points to graph a root function. So the first one is going to be 7, 2. The next one would be 4, 1. And the last one would be 3, 0. So there is our root function, our square root function. It's shifted 3 units to the right. All right, now we can look at the domain of this function. Well, the smallest x value at which it's defined would be positive 3. And it's going to go indefinitely to the right, so from positive 3 to positive infinity. And the range, well, the lowest y value is 0, and the highest y value is going to be infinity because this is going to continue to get higher and higher. So 0 to infinity. This next one is a polynomial of degree 3 because the highest exponent is 3. And notice there are 4 terms, which usually I try to do is I try to factor by grouping. So I'm going to group the first 2 terms together to find the zeros. And I'm going to try to factor this by grouping. So here I can take out the GCF, which is x squared. And I should get x plus 2 when I factor out the x squared. Over here I can factor out a negative 1, which would give me x plus 2. And you always want to make sure that these 2 factors are equal or identical because then you can factor that out. So if you factor that out, you'd be left with x squared minus 1. And notice that you have the difference of 2 squares there. So you have x plus 2, x plus 1, x minus 1. This here becomes those 2 factors when you factor the difference of squares. And you get your 3 zeros being -2, -1, and +1. Now you draw your coordinate plane and you put those points in. The three X intercepts are -2, -1, +1. And then one way to do this is to pick any point to the left, any point here, any point here, any point to the right. So you're testing these intervals to see if the graph is above or below the x-axis, whether it's positive or negative. So let's plug in -3 to see if the graph is above or below. So if you plug in -3 here, so I'm going to test -3. I'm going to test -1.5. I'm going to test 0. And finally, I'm going to test 2. All right, so let's plug in -3 into our factored version. So if you plug in -3 here, you're going to get a negative. So I'll just write negative times a negative times a negative, because this will be negative, this will be negative, and this will be negative, and 3 negatives is a negative. So that means the point is going to be below. So it's going to start here and go up, then it's got to go back down, then it's got to go back up, and there you go. That's what the graph will look like. You could test these points just to be sure that it's going to be positive here, it's going to be negative here, and it's going to be positive here. So there is your final graph. All right, now we can just look at the graph and see that the domain is going to be -infinity to +infinity, because this is going to go indefinitely to the left and indefinitely to the right. So that's our domain, -infinity to +infinity. And our range is also going to be -infinity to +infinity, because that's going to go indefinitely down and indefinitely up. So domain and range are the same in this case. And now we got to state where the intervals on which f is increasing and decreasing. So let's look at increasing first. Well, it looks like it's increasing. We're always going left to right. So it's increasing from -infinity to here, which would be -1. So it's going to increase. Oh, I'm sorry, hold on. Increase approximately the intervals for which f is increasing and on which f is decreasing. Use interval notation. Let's see. This one is a little bit challenging, I believe. Let me see if we can figure out why. All right, so it's just an approximation. So approximately, it's going to stop increasing right here, right? It's going to, so let's say, we'll call that -1.5. So from -infinity to -1.5, union, and these are always going to be open parentheses. For anytime you're dealing with increasing, decreasing intervals, it's always open parentheses. It's also going to be increasing from about here on, right? So from 0 to infinity. And then if you look at the graph, it's going to be decreasing from -0.5 to 0. That's the only interval in which it's decreasing from here to here. So -1.5 to 0. And that would do it. All right, the last problem here is they give you a graph, f, and they want you to state the local max and the local min. So this is considered a local minimum. Whoops. A local minimum right at this point. This is a local maximum, a local minimum, and a local max. So anytime that it's kind of like a parabola, that's the tip of the parabola, the vertex of a parabola. You can imagine or think of it as a parabola. It's not really a parabola. But that hump or that highest point is considered a local max, and this little dip is considered the local min. So let's state those. So this would be a local min. That would be at -1, 2, 3. 1, 2, 3, 4, 5, 6. So -3, -6. And then we have a local, oh, sorry, that was a local min. So that would be -3, -6. And then well, you don't want to put the parentheses because the parentheses are already provided for you. All right, for this point, that would be a local max, but it's the smaller of the two local maxes, so that would go here, 0, 0. And then the other local max would be here. That's the bigger of the two, or the higher, so that's 1, 2, 3, 4, 5, 1, 2, 5, comma 2. And their other local min would be here, and that's the bigger of the two, so or the higher of the two, so that's 1, 2, 1, 2, 3, 4. So 2, comma, -4. All right, and this one would be increasing from here to here. So that would be 1, 2, 3, -3 to 0. Union, decreasing, and then it's increasing from 1, 2, 2 to 3, 4, 5, 2 to 5. Oops, 2 to 5. And decreasing from -infinity to 1, 2, 3. And also decreasing from 0 to 1, 2. And also decreasing here, which would be 1, 2, 3, 4, 5 to infinity. And that concludes this section.